Hello. Today we are going to answer question 3, which is optical physics. This is from May-June 2025, component 5.1. All right. So, like I said, this is optical physics, and it's one of the common experiments that you will need to master as you go to write your IGCSEs. So in this experiment, you will investigate the position of the image in a plane mirror, use the ray trace sheet supplied, referring to Fig 3.1 for guidance. So this is the diagram which is going to guide our work alongside the instructions. If there is any trick I can share with you is be alert, be attentive to the instructions which you are being given, follow the reference of the diagram, and I hope by the time you get to the exam, you are already familiar with how to do this experiment in practice. The apparatus which you need for this experiment include the mirror, which can sit vertically, so it's actually plastered to a 10-angled iron. You need some pins. You also need a nice transparent ruler for straight edges and measuring, very sharp pencils. Okay. We are also given a protractor, and lastly we have a pin board, which is just a styrofoam block. This is where we are going to be working. Sometimes you may be given a T-square. I rarely use this, but it's used to make 45-degree angles, measuring, and 90-degree angles. This one is a 45, so two sides are 45. All right, so these are the apparatus you are going to need. Let's get to the work. Okay, we are asked to draw MR, which is a length of 10 centimeters. You are going to estimate the middle of this portrait, which is the ray trace sheet in portrait. You are going to estimate the middle of our ray trace sheet, so I guess this is the middle. And we draw a line MR, which is 10 centimeters long. So from here, there you go. This is MR. Okay, so first instruction has been satisfied. Draw a normal to this line that passes through its center. Label the normal NL. Okay, so we need to figure out the middle of MR. Okay, there we go, somewhere here. You don't have to beat yourself to be perfectly in the middle. All right, and using the protractor is one of the important skills that will be tested in these kinds of experiments. So we put this center of the protractor right on top of the middle of MR, and we mark, before we mark, we make sure this line of the protractor here is flush with MR. Very important for you to get accurate angles. I think this is good enough. I'm going to zoom in a little bit. There you go. So if you mark over here, this is going to be the angle 90 from clockwise and anti-clockwise. It's the same. The 90-degree angle is the angle of the normal with MR. So I will firmly hold my protractor in place so that it doesn't move. Then I mark, you can mark either here or here. It's the same thing. All right, so I have those tiny dots. Luckily, I can see them very well. I will now draw a line from this point, the 90-degree point, right through the middle, and I'll let it extend some considerable distance below MR. So this is my 90, and one of the important skills which you must sharpen is being able to draw a line in just one pass. You don't want to draw a line going up, then you come back, and you end up with a very dirty ray trace sheet, and that just puts off the guy marking your work. So this normal, we are going to label it N here and L over here. The middle here, we label it B. All right, so the second instruction has been satisfied. Okay, the next instruction is to draw a line below MR, so it's going to be right here, that's below MR, and it's going to be 10 centimeters long. From B, it's going to be 10 centimeters long at an angle of incidence I equal to 40 degrees. So using the guidance from our fig 3.1, we can see that this line is in this quadrant between M and L. So it's in this quadrant, and that line is going to be AB. The important part here is to measure the angle of incidence correctly. The angle of incidence is always measured from the normal. So we need to measure an angle of 40 degrees from the normal. I will make sure my protractor, let me show you. I'll make sure this line of the protractor, this one, is flush with NL, and this middle of the protractor is right on top of the center, which is B, right over there. Then I will measure my angles from the normal going in this direction. If you know the definition of angle of incidence, it's always measured from the normal. Very, very important point right there. I also want to point out something which I think I should have said earlier. All this work is being done before we put our ray trace sheet on top of the pinboard. Trying to draw nice lines whilst the ray trace sheet is on top of the pinboard is a nightmare. It leads to very dirty work, and you will perforate your ray trace sheet. You will make holes over there, and it will not be very clean. So I'm going to lay my protractor. Please learn to use the protractor. I cannot tell you how many times I have come across a wrongly measured angle of incidence. So I hold my protractor in place, and from the normal, which I am pointing, you can see the normal. We have 10 degrees, 20 degrees. Let me zoom in. So we have, from the normal, we have 10 degrees, 20, 30, and 40 is right over here. I'm going to mark it neatly, and we will draw a line from B passing through the 40-degree mark, and that line is going to be AB. So I will nicely measure 10 centimeters. This is point A according to our diagram, Fig 3.1. Okay, so far so good. Maybe just for interest sake, this is the angle of incidence, 40. If you are to draw or write things on your ray trace sheet, really recommend you keep things very neat. You keep your things very neat. So the mirror is nicely on top of the line MR. The next instruction says, place 2 pins, P1 and P2, on line AB. This is line AB. We are going to put pins here. So let's bring those pins. All right. One of the marking points, an important marking points, is that these pins, P1 and P2, they must be a significant distance apart from each other. So I recommend you separate them by distances which are approximately 6 centimeters, 5, 6, 7 there. Those are good distances. Those are good distances. So I'm going to really overdo it here and make sure the distance is, the separation of the pins is quite big. So here I have 6 centimeters, which is acceptable. I will lightly mark P2, P1 there, very lightly. I don't want to perforate I don't want to make walls on top of my ray trace sheet, so I have to be very light. Okay, so the 2 pins are in place. Now we get to the part where we look at the reflections of these 2 pins. All right, so please excuse my camera. It may get a little shaky now that I'm holding it in my hand. So this part of looking at the images of the pins is kind of like tricky for some students. But once you get used to it, it becomes a breeze. Now, I want to show you, this is the second pin and this is the first pin. Let me put a pencil on top of these pins. You see them like that? These are the 2 pins which we just put on AB. We want to see these pins through the mirror. So I'll move my camera and you will start to see 4 pins now. The actual pin, the other actual pin, and the image and that other image right over there. So we want to move our eyes so that those two images, they appear like one. In other words, the images are one in front of the other, directly in front of the other. You see, as I move to the other side, the image behind is going behind the image which is in front. And very soon, there will be one behind the other. There we go. Almost perfect. Do you see that? So I'll keep moving my eyes. My eyes are the camera in this case. I want you to really make sure you get this part right. This is the actual pin. The actual pin. Okay. And that one over there, I hope my pencil is showing. These two guys there, those are virtual pins. They are images of the actual pin. And look at the two images going one behind the other. Bingo. So now that the images are one behind the other, we want to put the third pin so that it is blocking those two images over there. So far I'm not blocking, I am blocking, I'm not blocking, I am blocking. So this is what you want to do, and carefully insert your pin. All right, so there we go. I think this is satisfactory. The third pin which I've put on the styrofoam is blocking the two images which are inside the mirror. And I'll do the same for the fourth pin. Not blocking, blocking, not blocking. Okay, so there we go. So I have this pin and this pin, actual pins, which are blocking the images of the pins in the mirror. When you do this, you have pretty much settled this experiment. These two pins, P3 and P4, they are going to form your reflected ray. So I will take off the ray trace sheet so that I can draw the reflected ray, and I'll show you. Okay, so I have removed the mirror and the pins. This is where the one pin was sitting and another pin was sitting right over here. Okay, let's label P3, P4. So the positions of the pins have been labeled. One way to check whether you were very accurate or maybe not so accurate is to see whether this line, which passes through P4 and P3, whether it passes through B. So if it passes through B exactly like this, it was a very good experiment. If it is slightly off suppose it was crossing B right over here, it was crossing MR right over here, it's not a big issue. You just ignore it. You don't want to be very far from the middle. You don't want to be very far from B, like somewhere here. You don't want this line to go and cross somewhere here. In fact, our examiner says you must be within 2 millimeters of B. That will be a good experiment. So you can measure this angle 40 degrees. You can measure this angle. It is 40 degrees as well. Okay, let's go to the next instructions. Okay, so we are asked to measure the acute angle alpha, and between this line, which is this line, and the normal NL, and we are told the acute angle is less than 90 degrees. I'm just going to measure this angle. I've already done so, and it's looking very much like 40 degrees, but let's measure it together. Okay. Quick recap. The middle of the protractor goes exactly over the crossing point of NL and MR, and there is a line, this black line. Let me actually show you again. This line here, okay, this line, it must be flush over this NL. There we go. Wait again. All right, so there is our angle alpha. All right, I can't zoom further, but there is our angle alpha. How do you figure it's 40 rather than 140? We are measuring from the normal 10, 20, 30, 40. That is the scale we use. This scale, which is on the outside, is measuring from that other side. Let me show you. From all this right up to here. It's not the angle that you want. You want the acute angle, the angle less than 90 degrees. So you go on to write alpha is 40 degrees. Now it is important to know how to write this 40 degree, the alpha angle. And by the way, if in your experiment you got something like 38, 39, 41, 42, that's accurate, that's acceptable. But I want to talk about the presentation of 40. If you look at the protractor, the smallest division is 1 degree. That is the least count of our protractor, 1 degree. So your readings are presented to the nearest degree. You should not end up with 40 point something, because the least count that we have is a unit. So we are writing our answers to the nearest units for this particular protractor that we are using here, which is the standard protractor recommended by our examiner. It should be to the nearest 1 unit. So we have seen that the angle alpha is 40 degrees. Please do not make a mistake of writing 40.0 because the protractor that we used can measure to the nearest 1 degree. The next instruction requires that we rotate our ray trace sheet. Okay, this side we are done with it. We are now working on this side. Okay. Now the instruction says draw a line below MR, and from fig 3.2 we can see the line is between R and N. This quadrant here, this is the quadrant we are going to draw. This line is 50 degrees, so the angle of incidence is 50 degrees. We line up our protractor nicely, and 50 degrees is right here, same as over here. All right, I am going to zoom in a little bit. Okay, unfortunately I have to push it over there. So the normal is NL, and from here we have 10, 20, 30, 40, and 50 there. So I have marked right here. I've marked from here, we measure our angle going over there. Again, I emphasize that you practice to use the protractor, as this counts for marks. Having correct angles contributes marks. Okay, so those are the two markings which I have made. I'm going to join that to be there you go. So this angle here is 50 degrees. Okay, and what do? We bring our ray trace sheet. We bring our ray trace sheet and we nicely line up our mirror with MR. We put our pins, before we put the mirror, we place the pins P1 and P2. Remember, they have to be far apart. I recommend 5, 6, 7 there. So P1, P2, that looks good. Okay, I just marked P1, P2, and now we put our mirror over MR, and we start looking at the images of P1 and P2 through the mirror. Just gonna put some light to keep everything very nice there. Now we want to put pins P3 and P4. I will point at this pin is a real pin. That's a real pin. And over there we have an image. And right where my pen is pointing, we have another image. We are going to move our eyes so that the images, you can see the images that are about to line up. We want the images to nicely line up one behind the other, like that. Let's get this in focus. There we go. And we then put pin 3 so that it is blocking the images of those two guys. Like this, blocking the images, you see that? Now pin 3 is what we see instead of the images. We do the same with pin 4. Pin 4 blocks pin 3. Sorry. Not blocking, blocking. Not blocking, blocking. Don't be confused by that image over there. We are not interested in that. It's the image of this guy. So let's see. Okay, go back in focus. Okay. Now this guy is blocking the other pin. There we go. Perfect. So that's how we place P3 and P4. A lot of practice, but you eventually get used to it, and it's actually interesting. Very nice. Okay, so we have removed the mirror and the pins, and this is our line passing through P4 and P3. Okay, now we are asked to measure the angle beta, and please take note, beta is the angle between MR and this line. Okay, let me fix here. MR and this P3, P4 line. Okay, so there we go. That's our experiment. Let's show how beta is measured. All right. You will notice from 0, okay, let's get this in focus. Okay, from 0, 10, 20, 30, 40. So beta is 40 degrees. We record beta and we go on to explain. We record beta as 40 degrees. Again, from our work, we saw that the angle beta is also 40 degrees. This relationship was very easy to deduce because we can clearly see beta and alpha are equal, or they are very close to each other. In some cases, they may not be exactly equal. You may have alpha being 38 and beta being 40, for example. Okay, at the end of the day, if alpha and beta have a percentage difference of less than or equal to 10%, then you can say alpha and beta are equal. Even if they are not exactly the same value, they may be 38 and 40, you will still say alpha and beta are equal, as long as they have a percentage difference of 10 and less percent. And the justification is the percentage difference of, in this case, it's actually 0 degree. They are equal to each other. Is close enough to be acceptable within experimental limits. All right. So I just want to point out that sometimes you may be told that instead of writing percentage difference, you may be encouraged to write something like the difference in angle of 0 degree or 1 degree or 2 degree. You just don't want to have very big angles for you to say they are equal. So you may say the difference between alpha and beta of 0 degrees is close enough to be acceptable within experimental limits. So either way, this is how you justify your results. You must use the results to justify the relationship or the statements which you are making. Some techniques to obtain accurate ray trace sheet include drawing thin lines, using thin pins, and placing pins far apart from each other. So I recommend that you go for pin separation of like 6 centimeters, but the examiner kind of is okay with 5 centimeters as well. Then you also have to look at your pins from the bases. So these are the techniques that we use to obtain accurate ray trace sheets. These are kinds of techniques that you actually read. You have to know them before you get into your IGCSE Paper 5 exam. They don't change. These are whenever you are working with pins and lines in optics, you can use these techniques. These are good techniques.